Hello and welcome to our session on Federated GraphQL. So in a previous session, we've already looked at what GraphQL is, but let's talk a bit about it, just to have a quick recap. So GraphQL can be compared and contrasted with the REST API. With the REST API, if you want information about a user, like the first request over here, you will get that information once you send your request, but you will get every single field provided by that endpoint. You can't pick and choose the fields that you want. In GraphQL, the benefit is that you can specify the exact fields that you want. So in this case, we're querying the user, first name and age. So our response has only the first name and age fields of the user. It doesn't have the other fields such as blood type and last name. With the REST API, the other interesting thing is that if you want information about a user and a product, you might potentially have to hit two separate endpoints. So you have two separate requests with two separate endpoints, and you get two separate responses. But with GraphQL, the benefit is that you can have one query and get the information for both the user and product in the same response. This doesn't mean that GraphQL replaces REST API. So the REST API is of course older, more mature, and technically has more support out there, although the support for GraphQL is growing, and it has grown quite a bit. Alright, so the main takeaway here is that GraphQL lets you pick and choose which fields you want to see in your response, and it also provides one single endpoint for all information from the client's perspective. So this is what the architecture looks like. We have our client side, which then queries or asks our backend graph for information and also changes it if necessary through requests. This though has a small issue. What happens when the graph gets really big? It becomes a monolith, and that's not nice because it's very hard to maintain and very hard to scale. Because if you have multiple people working on this one graph, it's not going to be easy. So the solution to this monolith is to split up this graph into tinier microservices that can be managed by multiple teams. So that's what we're going to do. We split that one graph up into multiple graphs. And we also have this gateway over here. And the purpose of this gateway is to still maintain the appearance of a single endpoint from the client's perspective. So from the client's perspective, they're hitting one endpoint, although there are multiple subgraphs or multiple microservices on the back end. So this gateway has this thing called a compose schema. And that compose schema is just a schema that's a combination of all of the microservice schemas. So this is actually quite tricky to create. The reason being is that you need to make sure it's valid, you need to make sure it's a proper combination. And there was a solution to do this called schema stitching, which was basically just combining all the schemas together. But that had a lot of boilerplate code and it was quite messy. So the solution to this is our hero, Apollo Federation. So Apollo Federation reduces boilerplate code and takes care of the heavy lifting for us. And it lets you split your subgraphs based on separation of concerns. So the schema stitching method was actually, it actually had this system where you split based on types. And so it was really messy. But Apollo Federation lets you create your subgraphs based on which team you want to work on that specific subgraph. So if you want team A to work on the review subgraph, the review subgraph can have basically anything in it, perhaps maybe corresponding to a few features or a single feature. So you can have that team work on that subgraph. So you basically split subgraphs based on who's working on which subgraph. We'll see a better example of this a little later, but that's a part of federation. And yeah, this is basically what the architecture looks like. So it's the exact same thing as what we just discussed, but there's this compose schema and query planner in the gateway. And what that does is when you have a request coming in, the query planner will split that request up so that it can be sent to the respective resolver and subgraph. And this concept of a resolver is the same thing as the GraphQL resolvers. So to recap, a resolver just helps you figure out what something is, and we'll see an example of it soon. So we have the data store. So these subgraphs can access the same database or different sources of data. It's fine, but the important thing here is that there are multiple microservices and each team can manage their own microservice. So let's focus on this test case where we have a review subgraph, a product subgraph, and a user subgraph. And although there might be multiple dependencies over here, we're going to focus on a single dependency, which is that a product has a list of reviews and each review has a product. So one single product has multiple reviews, but one review has a one-to-one relationship with a product. Let's look at our product subgraph. A product could have, well, there could be different kinds of products. There could be food products, electronic products, clothing products, medical products, etc. And the question here is, do all of these products have to go in the same subgraph? Well, the answer is no, they do not have to be in the same subgraph. They can actually be in multiple subgraphs, different subgraphs. And when I say be, I mean they can be owned by different subgraphs. And the reason for that is because we split up our subgraphs based on separation of concerns. So if team A wants to work on electronic products and clothing products, so then they get their own subgraph for this. If team B wants to work on medical products and furniture products, they can get their own subgraph for that and own these entities. Alright, so let's look at what this would look like in code. So I got this from the documentation, and the product would be a type. So this is normal GraphQL syntax with the type and product, and then the specific fields. Again, that's just GraphQL syntax. So we have this @key directive over here. So that's not something you see in normal GraphQL. What this @key does is it says that the primary key for the product is UPC. And when you use the @key directive, you essentially create an entity. So what exactly is an entity? Well, an entity is just something that you would like other microservices or other subgraphs to be able to reference and access. So we use the @key directive over here, and the key in this case is the UPC key. So the field UPC is the key, so UPC is in product over here, and it's a non-nullable string. And you can have multiple keys, so I can have this as a key and this is a key. So you can use this to access a payment in this case, or this whole key to access a payment. And you can also have compound keys, which are a combination of fields. But that's just syntax. The most important takeaway from this is that we're going to have a product entity, like in this case, and it's an entity because it has the @key directive, and the key is the UPC field. So now let's go to another subgraph and extend the entity. So we know that reviews is going to want to use the product in some way, because a product has a review and a product can have a list of reviews, sorry, and a review is associated with a specific product. So we define our review type over here, and our review is going to have an ID as well as an associated product. So this is fine. And we can do this because our product is an entity, because it has the @key directive, which means it can be used outside the product subgraph. So we have the review type, and notice that the review type is, actually, let me get a laser pointer. Yes, notice that the review type is not an entity because it doesn't have the @key directive. So in the review subgraph, we've defined the review type. Next, we're going to be extending the product type. So the product type is defined over here, but we can extend the type. So we're going to extend the type. And the reason we're extending it is because we want to reference it in our subgraph. And so because of that, we extend it. But note that you can also extend things that are in the same subgraph. But yeah, in this case, we're extending the product, and we note the key. So this has to match this. Next, we have to specify all of the fields that are used in the key. So in this case, we have UPC that's used as a field in the key. So we have to put the UPC field over here. Also note that we have this @external directive, and the reason for that is that we're just telling the system that this field UPC is defined externally. Note that we don't need to copy all of the other fields that we don't really need. We just need the UPC field because that's the key. We can also add our own fields if we want to. So we've added the reviews fields over here because from the reviews subgraph standpoint, from their outlook, a product has a list of reviews. But the people who own the product subgraphs, they don't really care about like the whole functionality of how reviews work and all of that, right? So they don't really even have that entity in the product itself. That part is just managed by the reviews team. Okay, so we have our reviews field, and it's a list of reviews. And note that there's no @external directive over here because this field is not externally defined. All right, so this is how we would extend the product entity so that we can reference it and use it in the review subgraph. Note that in both these subgraphs, you need to still do the normal GraphQL things that you usually do, which is write queries. So you extend the query type and then you add the queries that you want. So this is something you do in normal GraphQL that still applies here. So the only new thing that's come with Federation is the fact that you can split up that graph, and that brings along these directives like @key, @external, etc. Okay, so now we're going to talk about resolving the entities. And this is something that's done in GraphQL. And what it does, the resolvers have this. So if you have a query like this, where you have reviews, product, name, and price, what you're doing over here is looking at all the reviews and specifically the information you want to receive in your response. For all those reviews, we only want the product name and price. So a list of names and prices of all products with reviews. This is essentially what's going to happen. Alright, so this is our example query. And the resolver will just help you tell the system that when we get this keyword, so this reviews keyword, we want reviews. So we want a list of reviews. Or if we have maybe a product query, then we want a specific product. So this is a GraphQL concept. And inside the review subgraph, you can have these resolvers, like we do in GraphQL. And just like we have in GraphQL, you can make them asynchronous. So let's look at an example resolver. So let's look at the resolvers that are in the review subgraph. So we're going to have review or reviews, and then we'll have, so this will be reviews with an S probably. And then we're going to have product, because for all the reviews, you want to be able to get a product for a review. Actually, will that be an S? You don't say that. Okay. So let's look at an example resolver. So we have this resolver over here, and it has, so for a review, it will just give you the product. So this resolver is nothing but a function if you think about it. So this is a function. When you get a review as the input into the function, the output is going to be a product. So this thing over here is a product. That's it. This is just a product, and you need to specify type name product. So this is something you need to add. You don't need to do this in GraphQL, but you need to specify the type name so that the system will know that if you specify this type name, it's going to go to the product resolver and actually get the product information from the product subgraph. We also need to specify the primary key of the product, because that's how you identify which product you want. So yeah, we return this, which is, so this thing is just the representation of a product. Inside the product subgraph, we will have a product, and then we have this resolve reference function. So this is not something you typically have in GraphQL, but it's something you have in Apollo Federation. And what this says is that if you have a product and any reference passed to it and you want to get the product, this return type is just a product. So it gets reference.upc. And so that would basically give you the product that's required by the review subgraph, and you'd be able to get the response for this query. Okay, so that's our system. We've spoken a bit about the gateway and mentioned how the gateway has a compose schema, which is a combination of all these subgraph schemas, and the query planner, which splits things up and decides which resolver things go to. So let's look at an example query. So we have this client query, and it has reviews, product, and then name and UPC. And then this section just means that we want all reviews, and specifically in the response, we only want the name and UPC of the product. So this will be maybe a list of name and UPCs of products that have reviews. Okay, next, we also want the user name. So only the name of the user. And so what will happen is that, so these things will execute in parallel. So the request will come from the client side to our gateway, and then the query planner will break up this query into like this section, so the review section, and the user section. And since this is a query and not a mutation, it will send these parallelly. Of course, yeah, if the resolvers are async, okay. It'll send this parallelly to the specific subgraph. So it'll send this one to the reviews subgraph, specifically the reviews resolver. And the reviews resolver will look at this product thing, and since it sees product, it will ask the product resolver for information about that specific product. And that's how this part of the query will be constructed. There's also something called a schema registry that helps check the validity of the query and the response, and it makes sure that all of the subgraphs are backwards compatible. So their schemas are backwards compatible and the schemas are valid. But we've not mentioned that over here, but that's also part of this whole process. I'm mentioning it briefly, but it's implemented for us in Apollo Federation, so we don't worry about the details of it. Okay, so we have the reviews query, which has been evaluated and the response has been gotten for it, and simultaneously we've sent the user subgraph this part of the query. So the user subgraph resolver will just give us the name of the user, and finally the parts of the query, so the parts of the responses will be combined together and then sent to the client that requested it. So this is actually how the gateway is set up. I'm not going to dive too much into it, but the point I'm trying to make here is that it's very simple. Like, there's no boilerplate code. You just install Rover, which is Apollo's command line interface for managing federated graphs. Then you initialize your project, and you also install these libraries for the gateway and the server. The next step is then to just create this YAML file where you have a YAML file of all of your subgraphs. So you have your product subgraph, review subgraph, and then user subgraph as well. And then there's a routing URL and a subgraph URL. So what's the difference between these two? Well, let's go to my notes. So routing URL is the URL the gateway will use to send GraphQL operations to the subgraph at runtime. And schema.subgraph URL is the URL that Rover will use to fetch the subgraph schema during composition. So this is used for the schema, and this is just used to route the queries and mutations, so the operations to subgraph at runtime. Okay, so that's what routing URL and schema URL are. They can be the same link or they could be different URLs. It just depends whether the schema is on the same service. Okay, the next step is then to just pipe the output of this call into this file. Like, that's it. This basically will create your compose schema for you. This one command. It's amazing. You just pipe it, and then it creates this compose schema. So in the supergraph.graphql file. Next, you have the normal code that you usually do when you create a GraphQL backend. So you have the server, you have this extra thing which is for the gateway, and you also have this supergraph SDL, and this file path is just the same as the file into which we piped stuff into in the previous command. So that has the compose schema technically. And we then specify a gateway and server. And then this is the same thing you have when you have GraphQL. So this just starts up the server, and once the gateway is ready, it will log that. And if there are any errors, it'll catch those errors and log those as well. So that was so simple, right? The gateway setup for the schema stitching part, which was like theoretically quite messy to do. Most of that was just scripts that we ran to create the compose schema. And technically in this whole project, the Apollo server libraries that we've used are just 3. And this is just like an information dump that I put over here. It's just interesting to know what each of those libraries do. So Apollo Federation lets us make our service schemas Federation ready. Then we have the gateway, which is required for the gateway itself, and it helps distribute the incoming GraphQL API requests to the services in the backend. And then you of course have the Apollo server. This is what we need for the gateway API and each of the services we create. So that's the architecture of Apollo Federation. So a lot of companies have actually adopted Federated GraphQL, but the one that's quite interesting is that, so Netflix has actually adopted Federated Graphs for its backend, and they have this API called Studio Edge. And federated graphs really helped them split up things across teams in a very clean manner. So this is what they did. So they initially had this monolithic architecture where each client just hit this one endpoint for any bit of studio information. Then they had this direct access setup where the client could hit the specific microservice, but there was no single endpoint. So then they moved to the gateway aggregation layer, where you have a single gateway and then the gateway routed to a specific microservice. So the last stage that they have is a federated gateway. And with a federated gateway, so these blue things over here are actually just resolvers. So they can be, so technically they've shown it as part of the gateway over here, but you don't need to do that. I would actually draw this out so that these resolvers are either a layer before these microservices or a part of the microservice themselves. And they have another diagram on their blog which shows this better, and we're going to see that in a few seconds. But the benefit of this is that all the gateway needs to know is where the schema is and where the resolver is. The resolver code initially was in the gateway aggregation layer. So anytime a team wanted to change resolver code, they would have to amend the gateway. So what this has done is just given the engineers more domain control. So let's look at my notes really quick. Yeah, so the last stage, where the resolvers are a component separate from the gateway, gives developers more control over them. So you can just amend this one part instead of amending something and make a PR to like the gateway code, which is like a lot, and a lot of teams push code to that repo. But over here it's a separate thing, so you have more control as a developer. So this is the diagram I was talking about. They have a client which hits the GraphQL gateway, and this gateway will then route the request to the specific resolver, and the resolver can actually be in the same service, or so it can be in the same service as the rest of the service, or it could be a separate service on itself, but still owned by the same team. And of course, they have this schema registry, which we've spoken briefly about. The schema registry just helps the schemas be backwards compatible and valid. But quick note, credit for this diagram and the previous diagram to the Netflix blog, which is this blog over here. The fact that Netflix had a blog post for this is an indicator of how nice federated graphs are. And these are just the information sources I've used in this video. But that's basically it for the theoretical side of federated GraphQL. And I hope you enjoyed.